All right. Temperature when we're talking in terms of Celsius, and that you've probably heard of Celsius before. Okay, that's what most of the countries measure temperature in, except us. We measure in Fahrenheit. I put this up here just so you would have kind of perspective about it. We don't actually do anything with Fahrenheit in here. We don't do any conversions into or out of Fahrenheit. So you don't have to worry about that. That one is a little icky as far as trying to figure out the conversion. It's like 9/5 times minus 32. It's just a mess. Okay, so we don't mess with it. These are the two that we need to worry about and converting between them because we do this quite a bit during the year. So let me talk about what Kelvin is. So Kelvin is a measurement of molecular motion, essentially. So everything around you, doesn't matter what you look at, everything around you is vibrating. Okay, some things are vibrating in place, like your desk and anything solid. Okay, but they have a certain amount of molecular motion, and we can measure that molecular motion in terms of temperature. If we were to cool this down and keep cooling it and keep cooling it, eventually that molecular motion is going to slow down. And eventually we can get to a point where there's no molecular motion. Okay, in theory. I don't think that they've actually accomplished it yet. People are trying, like these really nerdy people in like labs around the world are trying to get to absolute zero. Some people feel that it can't actually even happen. So where all molecular motion stops, we call that 0 Kelvin. Where water freezes, it is 273 Kelvin, and water boils at 373 Kelvin. If we look at that in terms of Celsius, it's going to be a negative 273. Water is going to freeze or melt at 0 degrees Celsius, and it's going to boil at 100 degrees. So you need to be able to convert between these two systems. So Celsius will equal Kelvin minus 273. And I have those at the bottom of that page down there. I have those formulas for you. Kelvin then is degrees Celsius plus 273. Kelvin values can never be negative because you can't go below absolute zero. You can't make motion stop more than 0. Like if it's stopped, it's 0. You can't go negative from there. So Kelvin can never be negative. You can never have a negative Kelvin value. If you got a negative Kelvin value, you goofed something. Double check your work because something's wrong. If I have a negative Kelvin value in an answer key, I got it wrong. Okay. We did find one little minor hiccup on the answer key from yesterday. I uploaded a new one. So if you caught that, it was number 6 on there. So sorry about that. Let me pull it up real quick while we're thinking about it. If this will let me exit out of here. I don't know how to do this stupid thing. Sorry. I think we're just perpetually stuck here. Oh, that's why. I didn't see that. Answer key is over here. Answer key for you guys. So number 6 on the original answer key, I had the wrong value down here. It should have been 100 on the bottom, and then the answer should have been 3.8%. So sorry about that. I got it fixed, and I uploaded a new version to Classroom, but I don't know if it stuck or not. All right, let's try this again. Okay, so then if we look at density, when we're talking about density, remember we talked yesterday about how that is love. We have our unit, we have mass over volume, or an M over a V, if you need to remember the formula. Whatever units your mass was given in is going to come over here and it'll be the units for your answer. So if your mass was given in kilograms and your volume was given in liters, then your units for that density would be kilograms per liter. Okay. In lab, you're going to be doing some of these. You're going to be measuring things in grams. You're going to be measuring your volume in milliliters. So your units for density then would be grams per milliliter. Other things in lab that you're going to do next week, you're going to have grams, and then you're going to do length times width times height with a centimeter ruler. Well, centimeters times centimeters times centimeters is, right, centimeters cubed. So then your density would be grams per centimeters cubed. So whatever you have for your mass and your volume, they carry over to give you your density. That makes sense? All right. I will not mark you off on this, but notice that Kelvin does not have a degree sign. Kelvin's not measured in degrees. Okay? So it's just 83 Kelvin. If you write a degree sign with Kelvin, I'll mark it, but I won't take points off. Okay? All right, I want to go from 83 Kelvin to Celsius. What am I going to do? Back at your notes, what does it say to do to go into Celsius? Yep, so I'm going to subtract. So I'm going to go minus 273 here. Oh, I didn't do this. So I got negative 190. Is that what you got?
Yes.
Okay. Now Celsius can be negative. Kelvin can't. So here, you do not want to end up with a negative number. So here, what are we going to do to get to Kelvin? Add 273. All right, so I ended up with 356. So 356, and again, notice that I did not get a negative value there for, all right, a negative value, and I also didn't put a degree sign for my Kelvin. Bueno? Pretty good? All right, one more I do problem. We've got brick of salt. It's measuring 10 by 10 by 2 centimeters, and we were given a mass. We want to calculate the density. So the first thing I need to do is I need to calculate my volume. So my volume is going to equal 10 times 10 times 2. So what is that? Do that in your head?
200.
200. And what are my units on that?
Centimeters.
Cubed, right. Okay, so it's going to end up being 200 centimeters cubed. I don't know why my line went away. Let's try it again. I'm going to put my mass above here, which is 433 grams. And notice if I put my units in my work, they just flow right over into my answer. So 433 divided by 20 is 22. And that's going to be grams per centimeter cubed. Divide this by 200.
You said you divided by 20. Yeah,
20.
You divided it by 20.
There, better? It's been a day, you guys. I spilled my coffee. So 433.
Shouldn't it be 200? Yeah, shouldn't it be 200? Because 10 times 10 is 100 times 2 equals 200.
Yeah, it should be 200. What am I doing?
It would be 2.2.
Ay, ay, ay. I can't do, I don't seem to be able to do much of anything right today, you guys. Well, like I said, coffee. All right, is that better? Did I mess up anybody? Did I confuse anybody with my bad math?
I think we're good.
Okay. All right, I'm gonna